So we are given a car of mass 1500 kg. It's moving on a flat horizontal curved road. So it's going to do circular motion. So the radius of the curve is 35 centimeter. And the coefficient of static friction between the tire and the dry road, mu s is 0.50. So the car is moving on a dry road, so there is a friction between the tires and the dry road. So question A asks us to calculate the maximum speed the car can have and still able to make the turn successfully. B, suppose the car travel on this curve on a wet day and begin to skid when its speed reach 8 cm per second. Calculate the coefficient of static friction, mu s in this case. So class, kalau kita nak selesaikan masalah ni, pertama kita kena faham dulu untuk sebuah kereta yang berada pada permukaan jalan yang rata dan dia melakukan circular motion. So we have to understood what force is acting on the car and then what force is providing the centripetal force that enable the car to accelerate towards the center or enable the car to perform the circular motion. So what kind of forces is acting on the car? So basically the car have mass, so it must have weight downward. Then the tire of the car is contact with the surface of the road. So upward we have normal reaction force. And now we have to bear in mind, class, there must be a friction between the tire of the car and the road, whereby this friction is pointing towards the center of the circle. Why? Because this static friction force is responsible for opposing the independent motion of the car that is moving further from the circle. So kita nak elakkan kereta ni terbabas jauh daripada gerakan membulat ni. So kita punya friction antara tayar dengan kereta mesti menghala ke pusat bulatan sebab kita tak nak dia terbabas keluar. Kita tak nak kereta ni terbabas keluar daripada bulatan kita. Okay, so I draw the free body diagram. So I have weight, normal, and the static friction of the car is pointing towards the center of the circle. So you can see obviously the static friction that point towards the center will be our centripetal force, whereby the centripetal force, it can relate with the speed of the car, mv squared over r. Okay, so for a car move around a flat curve, so kita understood the static friction will be the force that provide the centripetal force that enable the car to move in a circular path. And then kalau you recall konsep static friction dalam topik 4, kita faham kalau kita recall back our concept in topic 4, we know that our static friction have a maximum value, whereby the maximum value is equal to mu Sn. So there is a maximum value that for the static friction to be exist. So the required centripetal force, or in other words the static friction force, in order for the car to make the turn safely is equal to the maximum static friction force. So kerana static friction force have a maximum value, so there is a limitation of velocity. Di mana kereta tu boleh bergerak round the flat curve and safely make the turns. Okay, safely make the turns. Our static friction will be maximum lah. Di mana dia sama dengan mv squared over r. So maximum speed tu adalah corresponding kepada maximum static friction that enough to provide the centripetal force that enable the car to make the turn. Okay, so dari situ kita boleh cari maximum speed lah. So kita ada Fs maximum equal to mv squared over r. So when it comes to maximum static friction means the velocity will be maximum lah. So maximum static friction is mu Sn equal to mv maximum squared over r. So for a car, if you refer back to the free body diagram that we draw for the car just now, for the car we said towards the center of the circle we have friction force, then we have weight downward, and then we have normal reaction force upward. So from the free body diagram we can see obviously our normal force actually is the weight of the car. So normal force is mg, we put it in mv maximum squared over r. So the m can be cancelled in the equation, so rearrange, we get the v maximum squared will be r mu s times g. So the v maximum, the maximum speed that still can make the turn successfully, will be square root of r mu s g. So then we put in the value, square root. The radius of the circle is 35. The coefficient of the frictions is 0.5. G is acceleration due to gravity, 9.81. So you might pause the video to calculate the maximum speed that the car can have to make the turn successfully. So when you do the calculation correctly, so how much you will get? I guess you will get around 13.102 meter per second. Okay, so this is our answer for question A. Then for question B, suppose the car travel on this curve on a wet day. So now sekarang mungkin hujan. So jalan tu jadi basah. And we find out that it begin to skid when its speed reach 8 meter per second. So we want to calculate what is the coefficient of static friction in this case. So kalau wet day, maksudnya jalan kita jadi licin. So bila jalan jadi licin, nilai coefficient static friction akan kecil lah. Jadi kita nak tahu berapa nilai coefficient of static friction dalam keadaan ni. So kita tahu maximum speed sebelum dia mula skidding cannot make the turn safely. Dia mula terbabas ialah 8 meter per second. So we understood the Vmax is 8 meter per second. So just now from question A, we already relate the Vmax with the R, mu, S and G. So kita terus ambil balik formula tu lah, square root. So Vmax adalah square root R, mu, S, G. So sama dengan 8. So nak hilangkan punca kuasa, kita square both side. So kita square both side. Kuasa 2. Dua-dua belah. So punca kuasa 2 dia akan hilang. So R mu S G. So 8 kuasa 2 64. So R kita masih 35. So mu S sekarang kita nak carilah sebab dia sekarang jadi weekday. So jalan dah licin kan, coefficient dia dah lain. G is 9.81. So 64. So pause the video, then you solve the question. So if you calculate correctly, I guess you will get around 0.186. Okay, so coefficient tidak ada unit. So yes, the value becomes smaller. This value becomes smaller. Then ini betul lah sebab why? Because wet road. Wet road smooth kan, permukaan tu jadi licin. So nilai coefficient akan jadi kecil lah. That's why masa hujan, when the day is raining, in a rainy day, kita kena reduce the speed lah. Bila kita masuk satu selekor yang tajam, kita kena reduce speed lah. If else, we cannot safely make the turns. Okay, we have to reduce the speed. See, we have to reduce the speed. Kalau waktu yang dry, macam ni, dry road, jalan tu kering, you dapati you boleh pergi laju sikit, you still can make the turn successfully lah. Tapi bila jalan tu wet, basah, nilai coefficient tu berkurang, then you punya maximum speed pun akan jadi kurang. Okay, so I hope you get the idea on how the car can make the turn safely.